Okay, so in this clip, we're going to look at how the valency of an element is going to be used to calculate the formula of a compound after those elements have combined. So in the previous clips, we've been looking at sodium, lithium, and magnesium, and also oxygen. And what we're going to do is use the valency for sodium being 1, and obviously magnesium 2, lithium 1, and oxygen 2, as we figured out in the previous clip. And we're going to use these to calculate the formula of each of the species that would be formed if they'd all reacted with oxygen. So we're going to take these as ionic compounds. We're going to react the metal, sodium, magnesium, or lithium, with oxygen in turn and evaluate the formula of the resultant compound. And we're going to take in each of these situations the valency, as we've said, and sodium has a valency of 1, oxygen has a valency of 2, sodium having 1 outer electron which it can lose, oxygen requiring 2 electrons to get to that complete octet. And once we have the valency of these two elements within the resultant compound, what we do is simply swap over these two numbers. And each element then picks up the number of the valency corresponding for the atom element that it has just combined with. So sodium oxide, as it forms, the sodium would pick up the number 2 from oxygen. Oxygen would pick up the number 1 from the sodium. And the resultant formula of sodium oxide would be Na2O1, meaning 2 sodiums for every 1 oxygen. Now, when we have formulae, we don't tend to write the ones. So we assume a 1 if we can't see a number. And so the formula would just be written as Na2O. Likewise, then, if we go through the other examples, if we were to look at magnesium, valency of 2, oxygen, valency of 2, again, swap the numbers. Oxygen picks up that 2, magnesium picks up that 2. Now, what that's done is given us a resultant formula of Mg2O2. And what we would try to do is cancel these numbers down because a formula is the simplest whole number ratio of elements in these compounds that we're looking at. We're looking at this calculates an empirical formula. And so because we've got 2 magnesiums and 2 oxygens, basically that's in a ratio of 1 to 1. There's the same number of magnesiums for the same number of oxygens. So we could cancel out the 2s and write 1s in each situation. If it had been, for example, 2 and 4, we could have calculated and cancelled down to 1 and 2, or if it was 3 and 6, for example, 1 and 2, etc., etc. So kind of like you would do in maths for fractions, simplification of fractions. But in this situation, 2 and 2 would cancel to 1 and 1. But again, we don't write ones. So the formula of magnesium oxide would just be left as MgO. And if we then just quickly do the final example, lithium is in group 1. And we're starting to see now similarities between things that react or things that are present in a group. Things which are in groups tend to react in similar fashions. The products of the compounds that are formed from those groups have certain similarities. That's why, as we'll look at, they are in the same groups. Sodium has 1 outer electron, as does lithium. Therefore, the resultant formula follows a similar pattern whereby we have 2 of the metal and 1 of the non-metal. So we have Na2O1 and Li2O1. But again, not writing the ones. So we can have this whereby we have a simplification and a simple swapping over of the numbers of the valencies. Once we've evaluated what the valencies are, we can then calculate the formulae. And I'll look at another couple of examples in the next clip, and then we'll go on to balancing equations and more complicated examples.